Okay, let us apply all the stuff that we learned in the previous video to this problem. So let's say that you have two sources of sound, S1 and S2, separated by a distance of 3 meters. Okay, there is a screen where basically that's where we're going to have the detector that is going to be placed 10 meters from the source of the sound. Okay, now the question is, oh, by the way, the wavelength of the sound that the speakers emit is 0.25 meters, and the question is, find the position on the screen where you have the first minimum. So we'll do a bunch of things. So find position on the screen for the first minimum sound. Okay, and then we can also do the same for the maximums, for the first maximum, and so on and so forth. Now we understand very clearly from this problem, from the symmetry of the problem, that at point A you will hear a loud sound, okay, because the two lengths are equal, so the path difference is 0, and so you'll hear a loud sound. So make sure you understand that. Okay, now our goal is to figure out at what point on the screen do we hear the first minimum, which means you have to ask yourself, what should the path difference be between the two sources and the point. So if you were to draw a line from source 1 to some point and then from source 2 to this point, we ask the question, what should the path difference be, the difference in the two lengths be, such that the we're going to get a minimum. Okay, so the first minimum will happen when the difference is equal to half lambda. All right, if you look at the conditions, half lambda, all odd multiples of half lambda is when you'll have the minimum. So we're going to find that. So let this distance be some let's just call it some y that we're looking at. Okay, and from that, from this point onwards, basically what we're going to have is that S2p, the length S2p minus the length S1p has to be equal to half lambda. And once you know this, we can figure out what y is. Okay, now to set this up, essentially what we're going to do is the following. We're going to figure out what S2p is and what S1p is, okay, by using Pythagoras theorem. Now if we were to draw the triangle for S1p, okay, this is basically the triangle that we'd have. The one side is going to be 1.5 minus y. Okay, so let me write S1p. So S1p from the triangle is going to be equal to square root of 1.5 minus y square plus 10 square, and then S2p is going to be equal to square root of 1.5 plus y the whole square. Oops, 1.5. Make sure I write this properly. So it will be 1.5 plus y the whole square plus 10 square. Okay, and we already know what lambda is in the problem. It's 0.25. So what we know is that this length 1.5 plus y the whole square plus 10 square minus square root of 1.5 minus y the whole square plus 10 square is equal to 0.25 divided by 2. So we need to solve this equation. If we solve this equation, life is good. We understand everything. We'll be able to obtain a result. Now solving this equation is not really that easy, because you see you have radicals and all kinds of stuff. But the general method of solving would be the following. What you do is you'd move one of the variables, one of the radicals to the right hand side. So you'd have 1.5 plus y the whole square plus 10 square will be equal to 0.125 plus square root of 1.5 minus y the whole square plus 10 square. Okay, now what you will do is you will square both sides. When you square the left hand side, you get 1.5 plus y the whole square plus 100, and the right hand side ends up becoming 0.125 square plus 2 times 0.125 times square root of 1.5 minus y the whole square plus 100 plus 1.5 minus y the whole square plus 10 square. So like I promised, this is not something, it's not easy, it's going to be painful. right? So you'll see a lot of the terms will actually simplify as we move on. Okay, so first when we square this left hand side, what we end up getting is 1.5 squared, which happens to be 2.25. So you get 2.25 plus 2 times 1.5 times y, so it becomes 3y plus y squared plus 100 equals 0.125 square, which is 0.015625 plus 0.25 times square root of 1.5 minus y the whole square plus 100 plus we have once again 2.25, so there's no minus sign, just dash, 2.25 minus 3y plus y square plus 100. Now if you look at these two sides, a lot of terms cancel out. First the 2.25 cancels out, the 100 cancels out, the y square cancels out. Okay, what we are left with is a 3y and a 3y, so that ends up giving us 6y on one side minus, I'm going to move this 0.015625 to this side, and all this is equal to 0.25 times 1.5 minus y the whole square plus 100. Okay, now what you can do is you can square both these sides again, and what you end up getting is the square of the left hand side becomes 36y minus 2 times 6, which is 12, times 0.015625, which happens 0.1875. So this is y squared, 0.1875y, plus the square of this, which we can basically ignore. It's going to be a small number, so we can just ignore that number. And then this on the other side, we're going to have 0.25 squared, which is 0.0625 times the square of all this, which happens to be 2.25 minus 3y plus y squared plus 100. Alright, so we're very close to the answer now. I know this is not pretty, but there's not much you can do here. So you get 36y squared minus 0.1875y is equal to, and if you multiply 0.0625 with this, you get this is about approximately 0.14 minus, we get 3 times all this is what is that? It's about 0.1875y. Oh, that's very nice. Plus y squared, which is, so it becomes 0.0625 y squared plus 100 times this is 6.25. Okay, now again you see a bunch of the things cancel out. This cancels out this. We have 36y squared, and this 0.062y squared is approximately the same, so I can write it as 36y squared is equal to 0.14 plus 6.25, which is about 6.4 approximately. Okay, and this gives me y equals 6.4 over 36 and the square root of that, which happens to be about 0.6 meters. Okay, so I know there's a lot of algebra. I don't think they'll really ask you this question on the AP exam, but just to, it's like an algebraic fun exercise. So at that distance you will find a position where you'll have the first minimum. Okay, so I would challenge you to find the position where you would get a first maximum. Okay, so try it out and see whether you can get the correct answer. So find the position where you'll get a first maximum. Go through the algebra. It's all, something new to learn, and figure it out. Okay, find the position of the first maximum.